Welcome to the video lectures in power system. Today we are going to solve load flow analysis for a system which is shown as this system with two generators, three buses and two loads. The data for all the buses and loads is given. Also the generator data and line data is given to us. Here in this problem, find all the voltage magnitudes in per unit and the angles in degrees at the specified buses, and also find the generators unspecified active and reactive power using polar form of Newton-Raphson method. So starting with on model development, we are going to use a software named as Power World Simulator, which is an educational version. It is free of cost and you can download it from Power World Simulator website. I will include the link in the video. So starting with our new case, first you will develop a new case like this. This is a new case. Then in edit mode, we will go to draw. Now we will choose our components like generators, buses. So here in this network, we will go for buses and we will add a bus here. As you can see in our problem, the bus base voltage is 200 kV given. So this is our bus number 1, which is having a rated kV of 200 kV. The voltage is 1.02 and angle is 0. So this is bus number 1. Here it is 200 kV as nominal voltage. Then we will go to the bus information. The voltage magnitude is 0.02, angle is 0, and this bus will be considered as a system slack bus because to solve a load flow we require a slack bus. Slack bus is required because the information about the losses is not available till the load flow analysis have been done. Also, I will put the bus in the right configuration. I will save this and OK. Now if I wanted to change the config orientation, then I will put it to up, save, and you can see your bus number 1 will look like this. In the same way, we will put all the 3 buses into the system. So in this way we have took all the 3 buses to our system. Let me change the nominal voltage to 220 kV as given in the problem. So till now we have fixed our 3 buses. Now we will develop the diagram by putting 2 generators, generator number 1, generator number 2. This is a swing bus as we have used as a slack bus. Now generator number 1 has a configurations or the parameter like this. So here from network we will use a generator and put the generator to this bus like this. A window will open. Now we will put parameters like voltage and magnitude of per unit is given. Display information. So now the generator base MVA. The base MVA of generator is 1.02 That is, if the base MVA is 100, then the base MVA will be 1.02, means 102 MVA or 100 MVA base. Then set point voltage is 1 per unit, as you can see here, 1 per unit. PG, generated power megawatt, and MVAR is 100 and 0.0. So we'll put 100 here and 0.0 here. Then we will put maximum and minimum limit of active power. So maximum limit will be 999 and minimum limit will be 0. After that, Qmax and Qmin. Qmin is minus 999, Qmax is plus 999, and in this way we have configured our generator number 1. Also, in the display information, I will use it to left. You can select number of generators from here. For now, I will use a dog bone, that is a salient type of generator. Save and OK. So like this, I am having a generator which is connected to a slack bus with 100 megawatt and 0 MVAR as its output right now. So this way we will connect the other. So we have connected 2 of our generators. We cannot see their magnitude, inactive and reactive power right now, because we have not connected the buses through the transmission line. As we will develop the model, we can see the power flows and the values of these parameters will change. Now it's time to connect our load. The load data is given here. The loads are connected to bus number 2 and bus number 3. At bus number 2 we have a load of 20 megawatt and 10 MVAR. So at bus number 2 from network we will select a load. We will connect this load here. The load have the parameters of megawatt, that is 20 megawatt and 10 MVAR. So 20 megawatt and 10 MVAR load. We will use the orientation to right. So like this, we have connected our load here. Now we connect our another load which is of 100 megawatt and 50 MVAR, which is at bus number 3. We will select load 100 megawatt and 50 MVAR. And the orientation to down, save and OK. So in this way we have connected the load. So like this we have developed the model up to this point. If we have connected the generator to the buses and load to the buses, now we will connect the transmission lines from 1 to 2, 2 to 3 and 3 to 1. There is the line data given from bus 1 to bus 2. We are having a line with these parameters. So select transmission line from 1 to 1 to 2. We have a transmission line here. While connecting transmission line, double click on the last position and you will see this window. Like we wanted to fit the parameter here, like the series resistance in per unit, which is given in 0.0085 per unit, 0.0085 per unit. Now the reactance value is given to be 0.072. The other parameter given is full B. The full B value, which is 0.149, 0.149, and the MVA limits, which are given as 200 or rated ABC. So we'll put it here as 200. Then we will go next section 200, and then it is 200. The nominal kV is 220 kV according to the buses, and the parameters are loaded here. Save and OK. So you can see here that the line being connected, and now you can see these values over here. In this way we will connect our another buses through these transmission lines. So you can see here that till now we have connected all the buses through the transmission line, and we have used the parameters as given to us. As you can see here, the parameters for transmission line from 2 to 3, and the parameter for the transmission line from 3 to 1. Also we can change what we wanted to see. As you can see, we can use all these parameters to see here. This will actually gives you the loading of the line in terms of percentage. So how much the line will be designed, then the loading must be not more than 85 or 80%. If the loading is more than 80 or 85%, the line will go to its thermal limit. Let us see. Till now we have connected our model. We will use some of the line parameters to view here. So to see the voltage at the buses, as we wanted to find out, we will use the fields. So in bus field, we will select the bus field and we will put the bus field here. We wanted to see the bus voltage here. So it will be used as the bus voltage magnitude for the bus number 1 in per unit. Then other field for bus will be its angle for bus number 1. We'll use bus angle. So we can see there are two fields, as number 1 is bus voltage magnitude and other one is bus angle. So you can see here we have selected from the fields for 2 of the buses.